Hello everyone, this is Emil Naruto. Welcome to my channel. So today I'll be explaining about the topic that is averages. So in this averages topic, in this particular video, I want to explain the very popular average that is the mean. So what do you mean by mean here? So mean. So how do you? What is the formula for the mean? Formula for the mean is nothing but sum of all data points divided by total number of data points, right? So this is the formula. uh, Mathematically you can denote it as mu is equal to sigma represents here, that is the sum. I is equal to 1 to n are the data points, and xi is the data point divided by capital N. So here it is saying sigma xi. That means here we are saying that we need to add all those data points divided by, we need to add the total number of data points. For example, I have some problem like this, maybe 2, 4, 6, 8. So if I want to compute mean for this, so how to do that? So I need to calculate first of all sum of all the data points, right? So what is the sum here? 2 plus 4, 6. 6 plus 4, 2 plus 4, 6. 6 plus 6, 12. 12 plus 8, 20. So you can say that 20 divided by, so how many total number of data points are there? So 1, 2, 3, 4. So this is the 4. If you do the calculation, you will get the mean as 5. So here, this would be your mean. This lies the number 5, right? So this would be your mean. So this is the mathematical way of solving problems, computing mean, right? So when I say mu here, when I say mu, see, when I say mu, this would be my population mean. Population mean. But but when I also have something called as sample mean. Earlier I have already explained what is mean by mean. Sorry, what is mean by population and a sample. So likewise, we have means for each of these, like for population as well as for sample. So what is this sample mean here? So it will usually be denoted by x bar is equal to sigma I equal to 1 to n xi divided by small n, right? So here, did you find any difference here? Earlier it was capital N, right? So earlier it was capital N, but now here it is small n. Why? Because that capital N is usually denoting the population. Here the small n is usually denoting the sample. So this is the formula for the sample mean. Now I want to let you know what is the outlier effect on the mean. So what is the outlier effect on mean? For example, see here, if I have some data points like this, 2, 6, 8, 10, 12, and I have one thing like 120. So if I want to compute the mean here, so in generally, what would be the mean for this? We usually expect mean to be lies in between this, right? So here I have 3 values. Here I also have 3 values. So our mean would usually be lies false here, usually, right? So here we need to have some kind of mean here. But what if I want to compute the mean here? 2 plus 6, 12. Sorry, 2 plus 6, 8. 8 plus 6, 16. 16 plus 10, 26. 26 plus 2, 28 plus 10, 38. So 120 plus 38, how much? 158. So 158 divided by total. In total, how many data points are there? 1, 2, 3, 4, 5, 6. Okay, so do the calculation here. 6 2s are 12. 3, 8, 6 6 are 36. 2, 0, 6 threes are 18, 2 here. So maybe around 26.3. So at 26.3, there lies our mean. Okay, here it is showing some 26.3 is our mean. Where is the 26.3? In between this 12 and 20, 120, right? There lies some, uh, there lies our mean, that is 26.3. Is this the correct solution for this problem? No. Why? Because here 2, 6, 8, 10, 12 are in as a kind of range, right? These are all having some two difference. Okay, the difference between 2 and 6 is approximately maybe 4, and here these having some approximately 2, 2, 2. So the difference is almost equal, but here the difference would be huge. The difference between 120 and 12 would be some double digits, right? So this would be treated as an outlier. So whenever an outlier is present in our data, so this all the data points are nothing but the data, right? So whenever an outlier is present in our data, so uh, that won't be treated, in our data. Why? Because if we treat that particular outlier in our data, uh, the mean would be somewhat different from what it is supposed to be, right? So for example, if we eliminate this 120 and calculate the rest of the procedure, so what happens? 38. We will get all the sum for all these data points would be 38. So 38 divided by 1, 2, 3, 4, 5. What happens? 5 sevens are 35. 3.056 7.6. That means there lies our mean 7.6. This would be the perfect value for the mean. So here what I'm trying to say is, if there is an outlier in our data, then definitely that would impact the mean here. Why? Because the mean definition itself is we are actually summing up all the data points here. We are actually summing up all the data points. So we are actually treating all the data points. If there is some huge difference between the data points, that is, if there is any outlier present in the data points, then that would definitely impact our mean, right? So, and what is the, when do we apply, I mean, when do we use this particular mean? So mean is used for the quantitative. When do we need to use this mean here? So mean is used for quantitative, or you can also call it as continuous or discrete. Quantitative or continuous or discrete variables, you need to you can use it on this particular data. Okay, and you can also use it over normal distributions. So again, this is some huge concept, normal distribution. So uh, mm, I'll explain this particular topic in the further videos. But for now, you just imagine this kind of a shape for normal distribution. So here the data is actually symmetric, right? So in an even format. So on this kind of even data, I mean, on this kind of even shape, evenly shaped data, you can use your mean. Okay, and when do we know? When we should not use? When we should never use mean. Never use mean. When we should never use mean. When there is outliers. When there is outliers in data, we should never use mean. Why? Because just now I have already explained. Just refer to that. Okay. When there is any outlier, then you will observe a huge deviations in the value of mean. And when you should never use if I say outlier in the data, that means it also mean like we should never use mean on the skewed distributions. On the skewed distributions, you would never use. What do you mean by skewed distribution? Again, this is a huge concept. I'll explain in the further videos, but for now, just imagine like this. See here, this shape is not a evenly distributed, right? This is an uneven data, okay? Or you can also imagine like this, either right-tailed or left-tailed, whatever may be there, but these are briefly treated as skewed distribution. You should never use this kind of mean on this kind of data, okay? Thank you.